All right, all you wonderful, amazing math pupils. Yes, 9 to 25. We will simplify radicals with complex numbers. Ooh, sounds a little scary. Don't worry, it's only September. All right, our perfect squares. Yes, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. I'm not micro machines. Ooh, we added -1. Math professional, please don't kill me if I'm incorrect. Square roots 1, 2, 3, 4, 5, 6, 7. Oh, because the square root of the perfect square 49 is 7, 8, 9, 10. And the square root of -1 is I. All right, so our goal here for number one, we have the square root of -180. Well, 180 is not a perfect square. So what we need to do is find the greatest perfect square that goes into 180. All right, well, 100's not going to work. 81 would be 162 if doubled. 64 times 3 is 192. 49, well, if we're working with 50 cents times 3, that's $1.50 minus the 3 is $1.47. Not going to work. 36, and let's do our 36. Let's try that. 180 divided by 36. Wouldn't you know, it does work. So the square root of -180 is equal to the square root of 5 times 36, which gives us 180. Oh, times -1, which equals -180. Now, in our answer, all right, the square root of the perfect squares, which in this case is 36 and -1, will end up on the outside of the radical for our answer. So the square root of 36 is, yes, double check me, 6. And the square root of -1 is simply I. Well, what's left inside? Square root of 5. Circle your answer. Now for number 2, looks a little different than your practice, but the square root of -245. Well, let's just check. All right, 100 times 3 is 300. Ooh, 81 times 3 is pretty close. 243, 64 times 3. We're getting there, but 49. Whoa, let's check it. 245 divided by 49 equals another perfect whole number, giving us 49 being our largest perfect square. So what you're telling me is, yes, I am telling you that again, it's equal to 5 times 49 times -1. And in our answer, on the outside of the radical, will be the perfect square. Square root of 49 is, great job, 7. Square root of -1 is, yes, I. Oh, we've used the 49 -1. Again, we still have the square root of 5. That's not a perfect square. Circle your answer. I will go over number 7 with you. If you look at 8, guys, always check the space between. Right there, I highlighted that plus. Just go ahead and combine your like terms. All right, so same thing we did with the variables, except this time we're just doing it with complex numbers. All right, so, what do we notice here? We do the big bag minus. What I like to do is highlight and flip signs. All right, so what I'm going to do is, I know if I distribute a -1 to a positive 5, it'll be -5, and -1 to a positive 8i will be -8i. Then with my pencil, I'll lightly get rid of that, and from there, I will combine like terms. I'm going to circle my 5. Can't be combined with -3i. Needs another real number. Oh, -5, but 5 minus 5, guess what, guys? There's nothing left. -3i minus 8i is -11i. Go ahead and circle your answer. But for 8, you'll just combine, and it looks like 9 and 10 as well. Whoa. Go ahead and complete the practice independently. Let's go.